All right, so let's take a look. This is my excellently drawn map of the United States. I used all of my artistic skills on it, as you can see. Now, let's take a look at high and low pressure systems. So first off, the things that we have to make sure we understand. Virtually every system in the United States is going to be either moving from the southwest over to the east or from the northwest over to the east, but everything always moves in this basic direction across the United States. All right. All of our parents come from the west some way, either northwest, southwest, or just west, and they work their way across. Okay. That's what's happening in the United States. Now, we have high and low pressure systems. So let's put a high pressure system right here. Now, our high pressure system, remember, is going to be spinning around this way, okay, because it spins clockwise. So that's what's happening to the air. It's circling around this way. That's what's happening as things are getting pushed out. Everything circles around. Now, for us here in North Carolina, think about what happens to us. As this high pressure system comes over, look at the winds that would be hitting us. We have this wind from way up here is getting pulled all the way down towards us. So when we look at that, if you think about it in general, the farther north you go, generally speaking, the cooler the air is. So when a high pressure system is coming in towards Charlotte, it's pulling all of this cool air down. So right before that high pressure system gets there, it should be cooling us off a little bit. Now, on the other hand, if you were right now sitting over at this wonderful city, let's just in the middle of the United States, think about what's happening to their temperature. The high pressure system has already passed them, and this is going through, and the wind is going down into the far south, and it's coming back up. Well, the farther south you go, generally the warmer it is. So when a high pressure system gets past you, it's pulling up all of this nice warm air. So again, that's why we associate high pressure with nice weather, because one, we've cleared out all of the clouds, and now after it's gone, it's pulling up warm air for you. So it's actually warming things up a little bit. So high pressure is often associated with that nice, warm, clear weather because of what's happening here. But the funny thing is, before it gets to you, it will often cool things down a little bit as it's making its way to you. All right, now let's flip it around. Let's do low pressure. So we put low pressure here. Low pressure is spinning in the opposite direction. It's spinning this way, okay? And all the way around. It keeps spinning around in that direction, counterclockwise. So if we're in Charlotte and this low pressure system is heading towards us, think about what's happening. Where is it pulling the air from? Air is coming down this way, it's warming up, and it's getting pulled up towards us. So when a low pressure system is coming across to us here in Charlotte, it's actually pulling up warm air, which then really, when you think about it, pulling up warm air is also going to cause the ground to warm up more and everything else. So you're going to get more evaporation and more water vapor in the air. So once you get more water vapor in there, then our low pressure system hits, which sucks all that up, which is going to generate lots of clouds. Okay, that's why low pressure systems are really associated with those big cumulonimbus clouds, the big thunderstorm clouds. Okay, then once the low pressure system is past you, see, look here, then you have this circling back. So the winds are coming up all the way north, cooling off, and then they're coming down. So when the low pressure system gets past you, then the temperature drops too. When as a kid, I always thought it got colder after a rain because the rain just cooled everything off. That's not actually what just happens. One of the reasons why after a storm, after this low pressure system moves through, that it's colder isn't because everything got wet. It's because the winds that are traveling are getting pulled from the north, and it's actually dropping the temperature because of that. Okay, so things to make sure we walk away understanding is that with high pressure, you're going to be pushing everything down and away, so you're not going to be generating a lot of clouds, and you generally have a clear sky. High pressure will start off with colder air, and then when it gets past you, it's going to warm everything up. Low pressure does everything the exact opposite way. Low pressure is going to build all of those clouds. It's going to build storms. It's going to build rain. Low pressure comes in, and it might start off with a slight increase in your temperature. Then when it leaves, it's going to drop the temperature down lower. Okay, so it's as complete opposite as it could possibly be. Low and high pressure is definitely something that affects the entire United States and the entire world. So, what I want and I hope you do is you start watching some of these weather reports, and you'll notice that when forecasters are making their predictions and they show you these maps, they always mark off here's where all of the high and low pressure systems are, and we can see them moving across. And what those forecasters are doing, they're looking at where the high and low pressure systems moving to, when are they going to get there, because they know that's going to have a big impact on the local temperatures and the amount of precipitation you're going to receive. Okay.